All right, welcome back to part 2 of the binomial distribution. We were just talking about Pascal's triangle and how we can count all these things up in a little bit nicer way. Okay, so to continue on this path here a little bit, the number of ways to get r successes from n trials is the r plus 1th value in the nth row of Pascal's triangle. Again, give me a minute and I'll explain this in further detail so it'll make a lot more sense. It's written as n over the r here, but there's no fraction. Okay, and this is called n choose r. Okay, so that means you've got n possible outcomes, and you want r is going to be the number of favorable outcomes, we call it. Okay, and this is called the binomial coefficient. Okay, so here's the idea behind this. Okay, so probability of x equaling 0. So of getting, that would be no successes at all. Okay, so that would be no blue. So that's going to be this path right here. Okay, so that would be, there's three possible, we're going to have 3 trials, and we're going to have 0 successes. So they're going to be all white. Okay, so that would be 3/4. All the 3/4, there's 3/4 probability of each of these blue spinners popping up. The spinner popping up blue, right? So, but now we're saying what's the probability that none of those pop up as blue? So that would be 1/4 white, 1/4 white, 1/4 white. So that would be 3/4 to the 0 power. Remember, anything to the 0 power is just going to be 1, and then 1/4 to the 3rd power gives us 0.016. It's actually 0.015 something or other, but we rounded to 0.16. Okay, probability of getting 1 blue, that's going to be down this path right here. Oh, sorry, this path right here, x equals 1, right? So that is 3 possible outcomes, but there's only one time does it come out favorably for us. So that's going to be 1 blue, 3/4 to the 1st power, and that's going to be 2 whites, 1/4 to the 2nd power. Okay, so 3/4 times 1/4 times 1/4 is going to give us 0.47. But there's 3 possible ways for that to happen. So we take 3, the number of possible ways for it to happen. That's where this Pascal's triangle comes in handy. 3 of those times our 3/4 times 1/4 squared gives us our 0.047. So 3 times 0.047 actually gives us 0.141. Okay, and then to get 2 blues, that ends up here, right? So remember, there's 1, 2, 3 paths to get there. So we're going to multiply our probability here by 3. So that given 3 possible trials, 2 of those being favorable would be 3/4, 2 blues, 3/4 times 3/4, and 1 failure, which is white, which is 1/4. So 3/4 squared times 1/4 is 0.141. But there's 3 possible ways of getting that. So 3 times 0.141 gives us 0.422. And then same thing with our last one here. Probability of getting all blue. That's the kind of the nice one, because there's only one way to do that. You've got the probability of, you've got 3 trials and getting 3 successes. That's going to be 3/4 all 3 times and 1/4 none of the times. Okay, so 3/4 cubed times 1 gives us 0.422. And again, there's only one way for that to happen. So you multiply those together to get 0.422. And then here's kind of the key to all this. Add these all together, add these all up, and you're going to get 1, which means that's all the possible outcomes. And again, these numbers were rounded here, so this number had to get rounded off as well. Okay, that's kind of how the binomial distribution works with Pascal's triangle. We're going to put it into practice with some more examples to help you better understand this. Okay, this here, I'm not going to necessarily suggest writing this down just yet. We'll use it a little bit first, and then once it makes more sense, then you can write this down here. But suppose x is a binomial random variable with n independent trials and probability of success p. Probability mass function of x is this big mess of stuff here, which is really basically what we just did back here. Okay, that's what this all is about here. Okay, so this is just the formula that's re-explaining what we just did. So I'm not going to go into great detail there because I think that's going to make it a little bit more, I want to make it less confusing instead of more confusing. So what's going to make it less confusing is to do an example here, which should help solidify this a little bit for you. But before we do that, let's take a quick little comedy break.
Oh my God, Kitty!
Mabel?
Okay. So let's take a look at an example. This will help make this make a little bit more sense. Example 6, write down the first 5 rows of Pascal's triangle. Okay, so we start with 1 up here, and then the rows underneath here. This is a 0 officially, so the one that's going to go into there is going to be a 1, and then the one diagonally down from that, that's a 1 and a 0, that's going to be a 1 as well. Okay, so write down the next row. 1 plus 0 is going to give us a 1 here. And now 1 plus 1 is going to give us 2. 1 plus 0 will give us 1. Okay. Write down the next row. 1 plus 0 is 1. 1 plus 2 is going to be 3. 2 plus 1 is going to give us 3. 1 plus 0 is going to give us 1. And then the last row here, 1 plus 0 is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And 1 plus 0 is 1. There's our first 5 rows of Pascal's triangle, which is going to help us figure out the rest of this stuff here. Okay. Beatrice the bunny has a 60% chance of making it through her entire course of the Bunny Equestrian Championships without knocking down a bar. If Beatrice runs through the course 5 times, determine her chances of making it through the 4 times without knocking down a bar. Before I go on any further, I forgot that this part right here does not count as the first row. So this is the first row. So this is row 1. And then row 2, 3, 4. So we need one more row. Okay, so 1 plus 0 is 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1 plus 0 is 1. So what these mean here is that there's 10 possible paths to get from here to here. So like one of them would be here, 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 there, there. Another one would be here, here, there, there. And there's 10 different paths to get down that. Okay, that's what's important for us. Okay. Now, again, back to Beatrice and her bunny jumping over the bars, trying to not knock them down, right? So making it through 4 times without knocking down a bar is what we're trying to figure out. Okay, so this is actually where this formula from the previous page is going to start to hopefully start making a little bit more sense, okay? So this here, probability of x. So we've got n over x, right? Which is, n is the number of trials that we're going to run. So the bunny's running through 5 trials, right? And we want to know how many times she's going to make it through at least, it said 4 times without knocking down a bar, right? So that's going to be our success, 5 over 5 and then 4 here, okay? 5 trials, 4 times being successful, okay? Now, here's where this is nice. The probability, this here is the probability of success to the power here, right? So our probability of success, they said in here, was 60% chance of making it through, right? So if we go back to this here, so we're going to do 60%, 0.6, and then it's the number of successes. So there's 4. We're trying to figure out what the probability of her making it through 4 out of the 5 times being successful, right? And then really the other 1 time is going to be not successful, right? So that's where the 1 minus p comes in. So if you think about it, if we do 1 minus 0.6, that is, in fact, let's do this over here. So this part for us is going to be 1 minus 0.6, which gives us 0.4. So if you think about it, that's the probability that we won't succeed. If you're going to succeed 60% of the time, the other 40% of the time you're not going to succeed. And then that's going to be the number of trials minus the number of successes. So that in this case is going to be to the 5 minus 4 power. So that's going to be to the first. So this means 4 times we're successful, 1 time we're not successful. That's what this whole formula up here is talking about. Okay, so oh nuts, I didn't copy that down in the right spot. I will do that. Okay, so now to calculate this thing out here, 5 trials, 4 being successes. This first one, remember, like this is always 0 successes, so 0, 1, 2, 3, 4. That means that this is going to be, there's 5 different possibilities of this happening. So we're going to do 5 times 0.6 to the 4th times 0.4 to the 1st. Okay, and that will give us our probability of making it through 4 times without knocking down a bar. Okay, there's other ways to do this, but it takes a lot of calculations. This is a little confusing at first, but once you get the hang of it, it becomes much less painful to go through and figure this all out. So let's calculate this out. We're going to do 5 times 0.6 to the 4th times 0.4 to the 1st. Oops, and I got a little bit too much stuff in there. So let's fix that. Okay, this is better. Push enter, and that means it's going to be a 25.9% chance equals 0.259. Okay, so probability of making it through 4 times without knocking down a bar, about 26%. Okay, making it through at least 3 times without knocking down a bar. So at least 3 times. This is where it gets a little bit more tricky. And I know you're like going, more tricky than this? Like, oh, you're going to be all right. It's going to work. Okay, so let's try this B here in a different color. Okay, so here's what we want to do. So really what this means is we're going to be successful if it knocks down, makes it through, is successful 3 times, 4 times, or 5 times. So here's what we got to do. We got to do 5 trials, 3 successful, 5 trials, 4 being successful, 5 trials with 5 being successful. And we got to figure out all these. Good news is we already did the 5 over 4. 5 trials, 4 times being successful right here. We know that this is 0.259 because we already had that. So we just have to figure out these two, and then we're going to add them together. Okay, so 5 choose 3. That's going to be 0.6, and we're going to have 3 successes, and then 0.4. That means if we got 3 successes, 5 trials, the other 2 are going to be not successful. Okay, and then the third, so the first, that's 0, 1, 2, 3. There's going to be 10 possible ways to do that. So 10 times 0.6 to the third times 0.4 squared is going to give us some number there. Okay, we can figure that out here really quick. 10 times 0.6 to the third times 0.4 squared gives us 0.346, we'll call it. 346. We already know that this one is 0.259 from up above, and then this one here, 5 out of 5. So that means we've got 0.6, 5 times are successful, and that means 0.4, we have no times that are unsuccessful. That's 0, and there's, let's see, so we got 0, 1, 2, 3, 4, 5. There's only one way for that to happen. That's to be successful each time. So 1 times 0.6 to the 5th times 0.4 to the 0 power. So to do that, we don't have to multiply by the 1. We just take 0.6 to the 5th power, and anything to the 0 power is just 1, so we really just have to do 0.6 to the 5th, and that gives us 0.078 equals 0.078. And now we add these all up, not this one here, just these right here. Add those all up, and that will be the probability that they will make it through at least 3 times without knocking down a bar. Okay, and putting that in the calculator, we get 0.683, so 68.3% of the time. 68.3% of the time, the bunny will make it through at least 3 times without knocking down a bar. Okay? All right, that's all we have for the part 2 of the binomial distribution. If you have any further questions on any of this, please feel free to ask. Thanks.